Simple. An example is just 35 miles per hour, how fast something is moving. Okay. Now we talked about velocity. It's the same thing as speed, but we add what? Direction. So we talked about the hurricanes. They use velocity. Now the way we represent velocity is because it's direction. We can also, instead of putting north, south, east, and west, we can also use positive and negative. And when we're looking at it from a graph standpoint, we talked about this yesterday. Positive is always going to be what? Either forward or to the right or what? Up. So forward is the same thing as going to the right. Everybody understand that? Okay. All right. Negative is the same thing. Be backwards or to the left or down. Does everybody understand that as far as graphing is concerned? Okay. Now, we talked about the fact that velocity starts with a V. Vectors start with a V, so we know velocity is a vector, and it's also represented by positive or negative. Okay. And it's also represented by arrows. So vectors. So if I draw an arrow to the right, that means I'm moving to the right. The length of the arrow also tells me magnitude, or how far, or how big it is. If I draw it small, that means smaller, so forth. Okay? Same thing with this. The resultant is also known as our what? Displacement. And that's what we figured out on the board, because when you drew that arrow, you figured out how far you were from where you started. That's also your resultant. So you're going to add up all your vectors in the x and y axis. I'm going to show you in a moment. And then the total is your displacement. So when you look at that line, that resultant line, that's a total of all the vectors, if you were to add them all up, that you traveled. Okay? And we're going to use what we call the Pythagorean theorem to find the overall velocity or displacement. Okay? So let's look at number one. All right, this one is real easy. We don't have to use anything on this one. All right, how many of y'all ever flown an airplane before? Okay, how many of y'all ever been on those moving sidewalks?
Oh yeah.
All right. What do you notice when you're standing on them, and then you start walking? What do you notice?
You go faster.
Real fast, right?
It feels weird.
Yeah, you're going faster. So take that into consideration. So it's called a people mover. In case you didn't know what it was called, it's called a people mover. Makes sense, right? To move people. All right. So the people mover is going 7 meters per second forward. How else could I represent 7 meters per second?
Draw an arrow to the right.
Okay. Or I can do what? What else could I do to represent forward? Put a plus sign. Exactly. So I can do that. I can put a plus 7 meters per second. Okay. And then while you are walking 3 meters per second, what? Backwards. I don't know why anybody would do that, but sometimes people want to do silly things. So I can do this. Minus 3 meters per second. Okay. What would be my resultant velocity? Okay, right. My resultant velocity would be a positive 4 meters per second. Okay, any questions on that? Okay, ladies, all eyes here. Okay, no talking while I'm talking. Okay, all right, that's my result before. Look at number 2. Here's another scenario. Okay, if you have a total x distance of -3, so we're going to draw a graph. Okay, all right, so we got our components. Okay, same thing here. Okay, where's -3? To the left. All right, so we got -3, 1, 2, 3. I'm hearing voices. Okay. Okay, x is -3, and now the total y distance of -4. Okay. So where's that going to be? Down. So 1, 2, 3, 4. Okay. The resultant in displacement is what? So what would I do? How would I draw that out? Okay, I'll make a triangle. So it would be here, here, and then it would be this would be my resultant force right here. Displacement. So I want to figure out this. So I get my numbers in. So 1, 2, 3. This will be 3. This will be 4. Or you can say 3 squared, 4 squared, and this would be c squared. Okay, and I'll work that out. So then I got c squared equals, okay, 3 squared plus 4 squared. And then I solve that. See, can you solve that? See what you come up with.
5.
Huh? 5, exactly. 5. Good. Pretty good.
You talked.
3 times 9 plus 4 times 4 is 16. Square root. Okay, square root. C equals, that's 25. It'll also be 25. Square root of 25 is 5. So now I know what my resultant vector is. So my displacement in this case is I'm 5 meters away from where I started. Any questions on that? Now, it gets a little bit more complicated. Now, let's say we have a scenario like this. You're lost. This is a situation where you might be lost. Okay, you're riding your bicycle. Okay, you got your lollipop in your mouth, and you start crying because you get lost. Okay, whatever. All right, so, we got a car here. That's even better. Now you got your license, or maybe you're driving illegally. I don't know. But all right, you're gonna go. What I like to do is this. I like to write down all my directions first. This is the way I do it, and I'll draw down west. Okay, and then we have south. Okay, did I put all of them up there? Now we have north. Okay, all right, let's look at our east. I go east 5, okay, meters per second. Okay, I go west, what, 9 meters per second. Okay, and I go north, 10 meters per second. Okay, and then I go east, 8 meters per second. And I go south, 15 meters per second. Okay, what are my resultant velocity and direction? Okay, so I'll add these up. That gives me what? 13 meters per second east. Okay, and this gives me 9 south and north. All right, because everything's got to be put on an X and Y axis. Okay, watch this. Okay, here's my compass. Okay, what direction is this? Okay, and east. All right, so here we go. So I got 13 east, so I'll be over here somewhere, and then 19 west. So what would I do with these two numbers? Subtract them, and what do I wind up with? 4 what? 4 east, supposed to be west, by the way. 4 east, so 1, 2, 3, 4. So that put me right here, okay? All right, so we cancel those out. We got those graphed. All right, I got 15 south and 10 north. What would that put me at? Negative what? 5. 5? 1, 2, 3, 4, 5. Okay, so here's my, and I'll draw my angle here. All right, so what would that be? 1, 2, 3, 4, then 5. Square, and C square. And then from there I can figure it out. Any questions? All right.